Vidas, and this is the demo of the NASA Exoplanet Detection with AI for AI Hoop Camp. So this app classifies a transit-like signals from NASA satellite curves and explains the results in plain language. So transit dips can indicate exoplanets, which are planets that are located outside our solar system. But they're hard for non-experts to interpret, and false positives are common. The purpose of this project is to address the accessibility gap. So essentially, we are going to um, classify, visualize, and explain because non-experts wouldn't be able to understand all this data better if they're able to visualize it and if it were given to them in plain language. So this is actually the homepage of this application. Users select the curve, view the chart, classify, get an explanation. So how would that work? We're going to compare at a glance. This is what a planet-like signal would look like, and this is what a false positive pattern would look like. So we're going to do an example. And we're going to start with clear transit. So the purpose is we're going to compare the view of planet-like versus the eclipsing binary pattern. So we're going to analyze the Kepler-like clear transit. So once we click Run Classification, we can see that the verdict is that this could potentially be a planet candidate with the confidence of 95% and its features. The explanation that we see here translates these features into everyday language with an educational disclaimer. So as we can see here, we can see like the brightness dips, which is basically what we want for it to be a potential planet candidate. We also have a warning right here that says in real NASA work, this would still need many follow-up checks. And this is just an educational candidate-like signal. So it's kind of warning to make sure this is just more so for an educational reason. Obviously, NASA would have to do multiple more tests. But we also have the transit depth, the SNR proxy, and the odd and or even consistency. Now we're going to compare this result, this Kepler, with the eclipsing binary style false positive. You can see it looks completely different. The flux varies widely. It's not as consistent either at first glance. So what does this mean? If we were to run the classification, we can kind of tell before we can see that this is a false, considered false positive. We can kind of see the model leans towards this false positive because it shows how lookalikes can fool a simple, there's a dip intuition. So the verdict looks more like a false positive pattern. 75% non-planet lean. Um, and again, the same disclaimer. The pattern looks more like a false positive, for example, an eclipsing binary or noisy non-transit, than a clean single planet dip. So this is kind of a great idea to compare like how lookalikes can kind of confuse some people. And this looks somewhat similar to the Kepler-like clear transit, except the dips aren't as consistent in the flux. So if we were to quickly look at the test, the ESS like shallow candidate. Um, at first one might assume, well, did someone look consistent? It could be a false positive. But let's run a classification to check. And this is considered a planet candidate, actually. Um, so this kind of shows how the noisy non-transit it should read as a false positive, but the verdict considers this a potential planet candidate. So this means the brightness dip looks like a repeating transit pattern. And again, NASA would have to do real uh, follow-up checks just to verify if it actually is a planet. And so this is just used for educational reasons and to what a candidate like signal can look like. So if we were to go to history, to be honest, all the curves that we've looked at are stored here with the date, the time, the name of the model, and the whether it's a false positive or a planet candidate. So these runs are saved for the session. And it's built with the next.js and a classify API. ML service is optional because the web API has a fallback. So this is an educational MVP on curated samples. The next steps are um, authentication, trained NASA label models, and an LLM and RAG explanations. So at the moment, this is what the app does. It doesn't show that many models, then again, but this is kind of based on data that's already pre-given. Um, Ideally, it would be where it would use real-time data from NASA, but that's a really far off future plan, so it's not possible at this moment. So that's kind of one of the drawbacks currently about this app. But so far it's pretty good at the already given models shown here. It explains what's going on at the graph. It even kind of shows if actually I kind of saw it real quick an example, and it has two comparisons. Um, We even have the mission listed here on the home page, which is to classify, visualize, and explain these models. Thanks for watching this live demo for the NASA Exoplanet Detection.versal.app. Thank you.